Welcome. Welcome to today's lesson. I am Siamasaka Kiandems, so I'm going to take you through a lesson for today. Well, the question states as follows, that a car travels at a constant speed of 20 meters per second for 20 seconds and is then brought to rest in 5 seconds by constant braking force. Draw the graph for the motion of the car. 2, determine the distance traveled by the car. 3, calculate the acceleration when a constant braking force is applied. And also, we are going to start with the part 1. And so we are supposed, first of all, to write that actually we are drawing a speed time graph. Speed time graph, meaning that in the y-axis, we are going to have speed. And then we indicate the units, which are meters per second. And in the x-axis, we are going to indicate that is time in seconds. So we are told that actually a car was traveling at 20 meters per second. And so the car was traveling at 20 meters per second. So you put 20 there. For 10 seconds. So for 10 seconds, it had a constant speed. So you put your 10 seconds there. And it was brought to rest in 5 seconds by a constant braking force. So it was brought to rest within actually 5 seconds. So 5 seconds plus 10 seconds, it gives us actually 15. So this is a distance, speed time graph that we have drawn. So this is how you can draw actually a speed time graph. And then part 2, determine the distance traveled by the car. So the distance can be made by partitioning this graph, because we are aware that the area under the graph gives us the distance. So we're going to have distance 1, which is under the graph for this rectangle. And we have distance 2 for actually the graph under the graph, which is for a triangle. And so distance 1 is equal to area under the graph. Which is equal to the length multiplied by the height. And our length, if you check, it is actually 10 seconds. So we have 10 seconds multiplied by the height, is 20 meters per second. It's actually 20 meters per second. And you notice that this second here and this second are going to cancel. And we are going to have 200 meters. When you multiply 10 times actually 20. And so that's why the seconds actually cancel out. That's why we say the area under the graph would give you actually the distance traveled. And so for distance 2 should be also the area under the graph. In our case here, you notice that for distance 2 for the area under the graph, it's actually a triangle. And we know the area of a triangle is half base times height. So distance 2 would be equal to half multiplied by base multiplied by the height, which is equal to half multiplied by our base here, which is actually 15 minus 10 for the triangle. 15 minus 10, which is 5 seconds. So we're going to have 5 seconds multiplied by the height, which is 20 meters per second. Do note that this second and this second are going to cancel. We can say 2 here, 1, 2 there, actually 10. And so we have our distance 2 as 50 meters. And so the total distance will be gotten by adding distance 1 and distance 2. And so total distance covered will be equal to actually distance total will be equal to distance 1 plus distance 2. This gives us actually 200 meters plus actually 50 meters. When we calculated, we found distance 1 was 200 meters and distance 2 was 50 meters. This gives us actually 250 meters as the total actually distance covered by the car. So the third part of the question is asking us to calculate the acceleration when a constant braking force was applied. So when a constant braking force was applied, it was after 10 minutes, 10 seconds. So that is actually deceleration. So we can calculate the deceleration which is actually acceleration is equal to final velocity minus initial velocity over time. And so we can look at what we have from this equation. We know that our final velocity will be equal to 0 meters per second, because actually the car during deceleration, it starts from 20 meters per second as the initial velocity, and it comes to rest. Okay, and so our initial velocity is actually 20 meters per second, and our time during that period is actually 15 minus 10, which is 5 seconds, which is actually 5 seconds. And so we may substitute in our equation. Our final velocity will be 0 meters per second minus our initial velocity would be 20 meters per second over the time, which is actually 5 seconds. So what we have is negative 20 meters per second divided by actually 5 seconds. And we find that our acceleration is negative 4 meters per square seconds. Okay, so this is how we can actually use these concepts to calculate distance on a speed time graph as well as the deceleration. So for those of you who want actually one-on-one lessons, you can contact me on my WhatsApp number. And we can arrange that we should be actually running online. And my number is +260 977 419949. I can take you through whichever physics course you are taking, whether you are taking O levels, whether you are taking GSCE, whether you are taking any other physics, then I can tailor it according to the course you are taking. I thank you.